Hey you guys, this is Mr. South. Just a quick lesson on radicals as rational exponents because we can write roots as terms with exponents instead of the roots. So thanks for watching. Don't forget to like, subscribe, and comment. So before we get into that though, it's important to remember all of the exponent rules because now instead of looking at these as roots or radicals, we're going to be viewing them almost specifically as exponents. Okay, because we look at exponents and we can add and subtract them. We can even multiply them, right? But what does it look like when we start dividing them? That's when we get into radical expressions. All right, so this is just an example of how it changes. Now we did talk maybe a tiny bit about this one here on the left, the top left here, the J. If we don't see the, I guess, the root value, like we do with that J, that's J to the power of 3, but the root, it's not a phantom 1 in these cases, it's really a phantom 2. Now that seems kind of weird why they would do that, because the 1th root is not really a root at all. It's just the regular phantom 1, okay? So we see enough square roots that the lazy mathematicians didn't want to write that 2 there anymore, and now you must suffer. But hopefully we see the rest of those, right? Like that's k to the power of 23, but it's the cube root of that, which becomes k to the power of 23 thirds. So whatever the root is, the value of the root here, I guess it's called the index for the root or the radical. That's the denominator in the fraction for the exponent. And whatever the actual power of the value is, like this one, 23, that's the numerator right here. So we're just flipping this, which allows us now to work strictly with just exponents and not necessarily have to worry about the root stuff. You can change it into exponential form, you can change it into radical form, doesn't really matter. And of course, if we were to look at this, if that 1 were something like a 10 maybe, a to the power of 10 nths, then it would be the nth root of a to the power of 10. Write the expression as a term with a rational exponent. Okay, so rational just means that it should be some kind of fraction. I suppose you could write the decimal, but we really want the fractions in this case. And I want to say that the homework wants the fractions as well. So we see the base value here is x, and the exponent will be some kind of fraction. So I just got the fraction line. That's not a negative, okay? So in my numerator, that'll be the power of the actual x, which was 3. And the denominator of that will be the index for the radical right there, 8. X to the power of 3/8, done. On this one, we want to write this expression as a term with rational exponent. Okay, so we're just going to simplify this. That's all we're doing. And if we remember, right, this is y to the power of 1/4 to the power of 2/4. And if you wanted to, you could simplify that right now. We're going to wait, though, because we're going to use the rule, right, power of a power. I got y to the 1/4, and then I would be multiplying this by the power of 2/4. Now again, it doesn't matter where you simplify, just as long as you end up doing it. But this would end up being y to the power of 1 times 2 is 2. 4 times 4 is 16. So I have y to the power of 2/16. I'll just simplify the fraction and make that y to the power of 1/8. Bam. Write the expression as radical. So now we're going in the other direction. We want to rewrite this now as a radical. And it should help us to remember that this 3 has a power of 1. That is not an exponent, that's a fraction. All right? The fraction exponent is only applicable to the x. Okay? So the 3 is going to stay 3, but I'm going to change the x. Right? The numerator was a 1, so it's x to the power of 1. And the denominator is a 2. So we'll just write this as the square root. I'm okay if you guys write the 2 there. I assume the homework will not be, though, because, kind of lazy math people. In fact, they probably don't want the 1 there either. So that is what I would leave it as. If I were doing the homework on the test, I would have left it as it was, though. That's a little extra work. Yeah, so on this one, again, the 3 still has a power of 1, right? So we still have this 3 here. It's not going anywhere. It's not going to change. But now when I look at that x, my numerator is 3 on that, so that's in the exponent. So that's x to the power of 3. But when I look at my root, sorry, that's a root, I needed the index to be the value of that denominator. So it's, and this we have to be very careful with. It's not 3 to the power of 4 that I've written there. It's 3 times the 4th root of x cubed.
Oh, I see.
Simplify this. Okay. Well, there's several ways you can go about this, and, well, maybe not. But we're going to follow the order of operations, all right? So the first thing we should do is parentheses, and we do have this set of parentheses right here, but there's not anything I can do on the inside of that thing. So we'll go right into exponents. There's lots of exponents. However, we'll work with the parentheses and the exponents with it. So for this, I'm going to distribute the 5, right? Power rule, expanded powers, I forget what they call it. But we're going to multiply those exponents. Now that's just in the numerator, right? So this will end up being x to the power of 3 times 5, so that's 15. Then I've got my base y, that's y to the power of 3 halves times 5. So I mean, we can show the work over here. 3 halves times 5. We can make it 5 over 1. And that y now becomes 15 halves. Nothing in the denominator changed. So I'm going to rewrite that without the slash stuff. So this is our new expression now with the 5 distributed into the parentheses. And just using our exponent rules, I'm going to start with the x's. Right, we want to break this up into smaller, hopefully simpler problems. And since this is division of the 2x bases, I'm going to take that power of 15, that's the power of x in the numerator, and we're going to subtract the power of x in the denominator, which is 5/4. And that will give me the new exponent for x, right? Now, yeah, some of you guys have the calculators that would do that for you. But I'm going to need common denominators to subtract these, all right? So I'm going to multiply the 15 and the 1 by 4, and that would give me 60/4 minus my 5/4, which ends up being x to the power of 55/4. And of course, that's just the x, right? Next up are the y values. So I've got y to the power of 15 halves. That's the exponent of y in the numerator. And we're going to subtract the exponent of y in the denominator, which is 1/2. That's pretty direct right there, because we already have the common denominators of 2. 15 halves minus 1/2 is 14 halves. And that would simplify even further to be 14 divided by 2 is 7. Bam. All right, simplify this. I don't know. I mean, I guess the order is still the same, right? I'm going to distribute that negative 2/3 into the parentheses right here. Some of you guys notice that exponent's negative, so you may have wanted to reciprocate that. However, I'm going to stay away from that for now and just do the straight distribution. So I've really got 27 to the power of negative 2/3. And I like to see my fractions like that. It doesn't really matter how you guys write them. And then I've got a to the power of negative 7/2 times negative 2/3. So my power of a ends up being, I can simplify this with the 2's, right? 7/3. That's positive now because we had 2 negatives multiplied by each other. That multiplication part right here for that exponent, you can plug that into the calculator and it should give you that 7/3 right there. So now I've got 27 to the power of negative 2/3 times a to the power of 7/3, and this is over a to the power of 4/27. All right, with this, I can combine my a values, since I have just a common base of a, and I'm going to take that 7/3 and subtract the 4/27. And these ones don't have common denominators, so I'm going to need that. I'll multiply the 7/3 by 9/9, which gives me a to the power of 28. No, what the heck? 63, man. 63/27 minus 4/27, which is 59/27. So that was just a. We still have that 27 to the power of negative 2/3, and we need to address that now because 27's, well, in thirds, it's a pretty unique number, okay? So I'm going to rewrite this though. This is 27 to the power of negative 2/3. So what I'm going to do is I'm going to make it 1 over 27 to the power of 2/3, just so that we can make that fraction as an exponent a positive. Again, all I did was reciprocate that. Okay, that's going back to, what was it, 6.1? All right, next I'm going to rewrite that as radical, actually. All right, so back to that point. 27, again, especially in cubes, is unique because it's really 3 cubed. And this is to the power of 2/3, right? Well, if I used the exponent rules on that, right, I've got 1 over 3 to the power of 3 times the 2/3 right there. And 3 times 2/3 is just 2. 3 times 2/3. And, well, 3 squared is 9, so it's really over 9 right there. Because it was multiplied by the a to that ugly power. So, I mean, you don't really need the 1 there. But that would end up being our final answer on that. I've got a to the power of 59/27, and then over 9. Sorry, my 9s look like a's, so that's not good. Hopefully you get the idea, though. So on this one, this is a fraction that's all inside that parentheses, so that negative 2/7. We could, on this one, actually go a couple different directions, and what I mean by that is we could simplify the inside of the parentheses first, or we can distribute that negative 2/7. All right, student's choice. Let's simplify the inside first. Actually, let's see if we even need that. So let's focus on the x's first, right? And again, the order is not going to matter there, but I've got x to the power of negative 2 over x to the power of negative 3/2. And then I also got that x to the power of 8 over there. So if we were to write this all as one base x value, I've really got negative 2 minus 3/2. Let me rewrite that. Minus 3/2 plus the 8. Oh, it's minus, and that's a negative 3/2 right there. I apologize. So in that set of parentheses, I got to do negative 3/2 plus 8. I'm going to skip the common denominator thing. All right, so I got that 13/2 by taking that negative 3/2, but I need common denominators before I ever add or subtract fraction. So I'm going to make that 8 over 1 become 16 over 2 so that I can get those denominators common. And now I've got x to the power of negative 2 minus, and negative 3 plus 16 would be 13 in terms of halves. All right, so I got that negative 2 minus 13/2, and I do need common denominators there as well. So I'm going to change that negative 2 into negative 4 halves, and we're going to subtract that 13 halves as well. And so I end up with x to the power of negative 17 halves. Now that's in the parentheses, right? So x to the power of negative 17 halves, which does not resolve the y's, which is what we will do now inside the parentheses. So my y's, I'll do over here. I add y to the power of 1 half, and we would subtract that negative 2 exponent of y. Now I'm going to change that to plus 2 because it was minus the negative 2. And I'm going to change that 2, instead of it being 2, we're going to change it to 4 halves again, right, this 2. So we end up with y to the power of 5 halves. And again, this goes inside the parentheses, y to the power of 5 halves. Not that everyone needs it. But on this one, we got the bases of x and y, and I'm going to distribute this negative 2/7 into the parentheses, okay? So by showing that extra step, right, it was starting as negative x was to the power of negative 17 halves. 17 halves. But now we're multiplying it by negative 2/7. Y was to the power of 5 halves. And now we're multiplying it by negative 2/7. And yeah, I guess now that we've done that, we don't really need that parentheses right there, right? All we need to do is combine or simplify the exponents. I've got x to the power of, the 2's cancel out, same with the negatives. So that's 17/7. Then I've got base y. Once again, the 2's cancel out. I still got that negative, so negative 5/7. I would be okay with this. There is just a slight possibility that they don't want that negative exponent, which means that you would have x to the power of 17/7 over y to the power of 5/7. Again, I'm okay with this one, but it is possible you need that one in black. If you were asked to simplify this, right, you got that first y, which has an exponent of 1. We have the common bases of y, but you got to take the 1 and add it to the other exponent, 1/4. Which would, yeah, because we're multiplying the same bases.
Right,
yeah.
yeah, okay.
So we'll add the exponents, which would have given us 5/4 right there. All right. I don't like the roots on this, so I'm going to rewrite it with rational exponents. To help us understand how this is going to work, I'm going to put that in parentheses. Hopefully that will help us, okay? So if I were just to look at the set of parentheses, then I'd have a base of x. That's to the power of 1, so it's really x to the 1/4. And that would be to the 10th root of that. Okay. I'm going to keep that x to the 1/4, but I'm going to change that, instead of it being the 10th root, we're going to make it to the 1/10, because that was an exponent of 1 there as well. And now, I've got a base of x, and I've got 1/4, and I'd have to multiply that by 1/10, power stuff. So this ends up being x to the power of 1. 4 times 10 is 40. Done. I suppose you could write it as the 40th root of x, but either way works. 64 to the power of 4/3. 64 is one of those unique values. I mean, we could look at it as a base 2 or base 4. And since this is the third, or 64 to the 4/3, or the third root, I can rewrite 64. You know, what the heck. We'll write it as a base of 2, okay? Now, not that everyone would do this step either, but I'm going to look at 64 and just see how it factors out. So if I divided it by 2, because it's even, that would give me 32, which is also divisible by 2. So I got 16, which is 2 and 8. 8, which is 2 and 4, 4, which is 2 and 2. So this is really just the prime factorization of 64. And I would expect that they would give you guys some pretty unique values like this on the homework as well. So 64 itself becomes 2 to the power of 1, 2, 3, 6. 2 to the power of 6. And we're going to take that to the power of 4/3. Well, the only reason I would do that is to multiply the exponents. So I've really got 2 to the power of 6. And I'm going to multiply the 6 by 4/3. You know, if it helps, look at that as 6 over 1. And the 6 and 3 will simplify to 2 and 1. So I end up with 2 to the power of, well, 2 times 4 is 8. And 2 to the power of 8, 64, 128, 256. So it looks like this equals 256. I did that, I would say, the hard way. The easiest way I know of is to plug that into a calculator. 256 is one of those special values, and we do love it. But that's a negative exponent, so I am going to change this to 1 over 256 to the power of 3/4 now. That's a positive exponent. And yeah, that's something that I can plug into my calculator. All right, so my calculator gives me 64, so it's really 1 over 64. Done.